Let me see.
All right, no, it's on record now.
Okay, so you are now the host. So, of course, we have been taught before now. I believe we have been taught what all about carbon. Just to refresh our mind, we say that carbon is in group 4 in the periodic table. It is tetravalent. The reason why we majorly call it tetravalent because it has 4 electrons available for bonding. It has 4 electrons available for bonding. And then which other thing can we say about carbon? We have the allotropes of carbon, which is graphite and then diamond. We can see our teacher explaining graphite being used as an electrode, and of course it's an example of an inert electrode because it doesn't take part in the chemical reaction during the electrolytic process. We see that also. And then diamond does not conduct electricity because it doesn't have free electron. But graphite does because it possesses free electron. The whole electron present in diamond was used to form bond. And that is the reason why we see that diamond is what? Octahedral in shape. Octahedral. In the place of graphite is hexagonal because only 3 of the electron, only 3 of the valence electron were available for bonding. The remaining one was there, and that is the reason why graphite can be able to conduct electricity. We'll not be dwelling much more about what they call it, carbon like that, because I believe before, sir, I hope we have done carbon already now. So I just move ahead to where I'm supposed to cover.
Yes, sir. You can go on.
Right?
Yes, you can go on.
So we will be looking at coal. We'll be looking at coal, which is spelled C-O-L. I'm sorry I couldn't use the blackboard atom. And even though I want here to power the laptop to do that, so I'll be sharing my screen.
No problem.
I'll be sharing some little note on the screen. So you go to the screen and then you see what is there. So when we talk about coal, we talk about coal is actually formed from a plant, remain on the ground. And when this pressure of temperature acted on it for a long millions of years, what did it lead to? It gives us coal. Of course, we have different type of coal. I want to share my screen now. We have different type of coal. And these various type of coal, they are formed in stages. I'm going to remove you as this thing now. They are formed in stages. I want to share this screen and I need to be a host. They are formed in stages. Okay, I still recording. Most of all this code, they are formed in what? Stages. They are formed in stages. Please let me share the screen so that you can see what I'm talking about. So if you look at the screen now, can we all see the screen? Can we all see the screen? Look at your phone now. You can see the screen. These are the 4 type of coal, the 4 stages. The first coal we have there is pit coal. Pit coal. The next one is lignite. The next one is bituminous, and then last one is anthracite. And all these coal, these 4 coal, the percentage of carbons varies. And the soot production when they are being burnt also include. From pit coal is going to produce more soot, lignite less, bituminous less, and the anthracite is going to produce lesser. Then if you look at the percentage of carbon, pit coal has a lesser amount of carbon compared to lignite. Lignite has more amount of carbon more than pit. Bituminous have more amount of carbon more than lignite, and anthracite has more amount of carbon more than bituminous coal. Anthracite, of course, has about 95% of carbon. Other things present there can be natural gas, other little component. That is what makes up the 5% of it. I think bituminous have about 85%, then lignite has about 75%. It has about percent of, and if I put in an arrow there, what am I showing you? I'm trying to let you know that from peat coal, you get lignite. From lignite coal, you get bituminous. From bituminous coal, you have anthracite, which is very rich in carbon. Now we have understand, see what coal is all about. The beginning of the class, I told you that coal is formed from dead organic matter, like plant like this. After they have still in the ground for a long time, you see them long time. When all this temperature act on it, pressure act on this material undergo metagenesis. There are so many processes that to undergo, but to be bothering our, just put that from peat, you can get lignite, for lignite you can get bituminous, and from bituminous you might get this thing. Another good information that is very, very important is that in our country, where can we find this coal? Of course, there are places where we can find coal in Nigeria, like a place Enugu have a lot of coal. Enugu has a lot of coal there. There are a lot of coal in Enugu. You can see that. You can also see some in Onitsha too. There are still some enough of coal for Onitsha, and this coal is very, 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 very good. It's also used to generate power in steam engine. And look at Nigeria, of course, we are still suffering from power supply. You can see what the previous lesson from coming out so beautifully when I use if I use my laptop. It is because of power. And of course, if we can utilize most of this coal, we can actually generate power for our country. So as we are teaching our students, we should make them know that subject matters, how they can be able to solve societal problem. That is what makes the subject more interesting, and that is what makes the students to gain interest to pursue career in chemistry. You can see Onitsha and Asaba, yeah, we have coal, but if you look at most area in Delta State, especially the Isoko area, most of you agree that the Isoko, they have been clamoring, if you have been listening to news very well, they have been clamoring for light, and we have this material. All we just need is to just fund the project, and you see that your place will light up. Coal can also be used for that, and coal can also be used for the production of fuel. All this our fuel we use can also be used for the production of fuel. You can get that by hydrogenation. You can hydrogenate the coal to some extent. You have enough. We can use it to produce fuel. We can use it to produce fuel. I move to the next step, one which we call coke, which is called coke. Of course, when from coal, you can get coke. We get coal from where? Coke. How do we get coke? We get coke by heating bituminous coal to a very high temperature of about 1,300 degrees Celsius. So you can see from coal, we are moving to coke. From coal, we are moving to coke, get coke. So when you heat this thing to a very high temperature, you are going to get what we call, you're going to get bituminous. If you heat bituminous coal about 1,300 degrees Celsius, in the absence of air, you are going to get what we call, you are going to get coke. We are going to get coke. The question is, why are we doing this thing in the absence of air? So many of us will be seeing the limited supply of air in the absence of air. It's very, very important for us to understand. We know that there's a particular element present in the air that supports combustion. And this gas in air, or this gas in air, so not element, gas in air that actually support combustion, is all the relationship between oxygen and carbon. Bituminous coal, of course, has 85% carbon. Then if you do it in the presence of air, instead of getting coal, you find out that your bituminous coal will burn off. At the end of the day, you will not have a tangible product. You will not have a tangible product, and the aim of that experiment or of that practice will be defeated. In case your student asks you, Ma, why is this thing done in the absence of air? Why is this thing done in the absence of air? Of course, we can also see that this coal of 18 is also mainly used as fuel. It burn practically without no smoke. All those things like this, they can also be used for fuel, as I've told you earlier. Coke, of course, can also be used as a reducing agent for the extraction of metal, and used as a reducing agent for the extraction of metal. We can see that it can also be used for the production of water gas and producer gas, as the case may be, which we will discuss later in this class. Water gas and producer gas. We can see many nice. Or we just need the power that move to the next topic, which that is the next topic. Any question? Any?
Please, I have a question. I don't. When you said coke.
Yes.
Agent.
Yes.
Please, that on the game.
As fuel, if you can be used as fuel as a heating source, can be used as a heating source. When we say as fuel as a heating source, are you getting me? And if actually want to use it as well as majorly all this petrol, as the case may be, you need to hydrogenate it. You need to hydrogenate it because those are fuel products are usually mainly carbon and hydrogen. Then when we say as a reducing agent, if you look at the extraction of iron specifically, what they use to remove the oxide from the iron is coke. Coke. Any other question, ma'am?
No.
Yes, I have a question.
Right. Then we proceed to the.
Okay, sorry, I didn't get, why did you say it's always done in the absence of air, in limited supply of air? I didn't get that.
Okay. When we say absent of air, you know when you react carbon and oxygen, what's the percentage of oxygen in air? We have about 21%. Two of us.
True.
Yes, we have 21% of oxygen in air. Then if we are actually burning the bituminous coal and you want coal, you are producing coke in the presence of air, you end up losing the bituminous coal. So it will not undergo that what will they call it? That
Gasification.
destructive distillation process. That destructive distillation process will not go out smoothly. You find that what you will be doing will be burning carbon and oxygen to give you carbon dioxide or carbon monoxide. The case may to avoid that or in the absence of air, so that destructive distillation process can go on smoothly.
Okay.
All right. We proceed to a very common one, which we call the carbon black and then charcoal. Carbon black and then charcoal. When we talk about carbon black, in a simple note, we say that carbon black are carbonation. Carbon black are by burning carbonaceous material. What are carbonaceous material? Carbonaceous material are material that contain carbon. Carbonaceous material are material that contain carbon, and they surround us. They surround us. Our plastic is a carbonaceous material. Our wood is a carbonaceous material. Even they surround us. There are many. Even your biro cover, all those things, your rubber shoe, all those polythene, PVC, all these ones we have. So majority of them, they are all carbonaceous material. We can now see that without carbon, majority of us will not be surviving and will not be looking good in this society. Without carbon, majority of us will not be looking good in this. Okay, sorry. I think I missed something for you people. So before I move back, so I don't want to breach this thing. We look at destructive. Did I give you people destructive distillation of coal? I think I missed something from this. I don't share a screen now. So look at this one is talking about the destructive distillation of coal. Please, I'm sorry, you can just go back to your screen and look at destructive distillation of coal. So when you from coal, you are going to get coke. From coke, you are going to get ammonica liquor. Then from ammonica liquor, you are going to get coal tar. Then if you look at that coal tar, we have so many. We have all these products are very, very useful. That you can get what is quota, not quota. It cannot going to be quota. You're going to order coal gas. It's going to be coal gas. That word is not quota, please. You can correct it. It's going to be coal gas. I think it's going to be coal gas. I'm in the lab. I just tried to grab this thing in hurry. I don't want to breach the class. I think it's coal gas. That one will be going to be coal gas. Maybe I will correct that. Please check anybody who can correct that for me. I think the last one don't need to be coal tar. It's supposed to be coal gas. Am I correct?
Yes,
check
it's coal gas.
And just check. It's coal gas, Abi?
Yes, sir.
Eh?
Coal gas.
Okay, thank you. Please, that last one should be coal gas. And so if we look at coal, we now see that coal can give to coke. Coke can give us this ammonica liquor can be used as fertilizer.
Yes.
And today we are complaining of our agricultural products are not doing very well. And we have all this material within our reach, which you can use to boost our CGPA. And all these are information you need to tell the children. Then you see for ammonica liquor, we still get coal tar. We have all this benzene. We know benzene very, very good. In fact, there is most of the production of detergent. Can we do without benzene? No, we cannot do without benzene. The structure benzene must be there. We have phenol, which can be used as antiseptic or toilet, and the rest they are there. We have toluene, we have naphthalene, and all these things are very, very useful. All these products we see that is present in the coal tar can be separated from each other using fractional distillation. And the reason why we can use fractional distillation is because they all have different points. You can separate them from our quota. You still separate them from our quota, and then, of course, if we need to be frank, here, the most suitable site for the just concluded refinery Dangote Lagos, following law practice, because if you are building an industry, it must be closer to raw material. Here we have Enugu, we have enough coal in Onitsha, we have enough coal in Asaba, and then in Delta State, Bayelsa, there is enough crude oil. And you now see that crude oil will now be taking a long distance from here, taking maybe through ship or cargo from here to the other side, to that side. Before it will get to that side, maybe thief and the guys must have collected their smoke. But the distance from all this place is supposed to be sighted around here. They will now see how politics is coming into play to slow down the economic progress of the country. I know that one day it's only God that is going to help Nigeria and open the eyes of Nigeria. Of course, if all these things are there, we have all this material present there, all this one will make things to work out very, very well. We have naphthalene, toluene, all those things are rich things. I'm sorry for cutting you people from that. So we move back to our lab.
Hello, sir.
Okay. Yes, I'm with you. Go on.
Just check, and we have coke, ammonica liquor, water, Are you with me?
Yes.
There's quota, and there's also in that destructive distillation of coal. Are you with me?
Okay. There's quota.
There's quota and also coal gas. Both of them.
Okay. The
And
last one come be is now quota. Okay.
the last one is
Okay,
coal gas.
And maybe what you just need to know.
now coal gas.
Yes, in destructive distillation of coal, we have basically 4 products. The
Okay, which are all these ones I just
yes,
mentioned
You
now?
have coal, ammonical liquor, coal tar, and coal gas, which is the
Yes.
last one of them.
right.
Okay. Please, you can correct it, please. Just correct. I'm in the lab, please.
Okay,
I don't want
so
to brief this and this, so that is the reason why I actually
I think it's also better for
just
students
in
know
how put it
their
out.
state of matter.
Eh?
So let the
Okay,
students
thank
also
you.
know their state of matter of each of them.
Okay.
Those are the
You
solid.
can see that the coal gas, the coal is solid, coke is solid. Then when you are coming down, you are coming ammonical liquor is liquid, coal tar is also liquid. That is why you can carry out what you call your destructive distillation. Then when you come down, you have the gas. So all this thing is telling you that from solid, you can move to liquid when you are heating. From liquid, you can move to gas. The 3 state of matter primary is what is being exhibited in that state. You see your coal and coke existing in the solid state, ammonical liquor, and then coal tar existing in the liquid state. Then we have our gas, the state of matter. So we go back to about a major material topic. You get your blood there. I want you to see